Hello, and welcome back to my YouTube channel. My name is Professor Govala, and today I'm going to be doing two current mirror examples, where for the first example, we're tasked with finding this I out, which is flowing right here, for a given I ref is equated to 4 milliamps. And again, if we remember, this I ref is basically coming from what's called our band gap circuit. And in a video that I made before this called Current Mirror Clearly Explained, which I will post in the top right hand side corner of this video, I explained that a band gap circuit allows us to essentially have what's called a golden current source, where our current is independent of our supply voltage and temperature. Now for a second example, we're tasked with finding this V out, which is the voltage across this 3K ohm resistor for this complex circuit. And what I would encourage the viewer to do is pause the video and try to see if they can solve these two problems, and then come back to the video and see if you receive the correct answer. Okay, so for the solution for this problem, I'm going to say then that I out is equated to this I out 2 plus this I out 3, where I out 2 is the current flowing through my M2 transistor, and I out 3 is the current flowing through my M3 transistor. And so we know then that I out is equated to I out 2 is essentially going to be this I ref mirrored, because we see that M1 is connected in a diode connected configuration. And again, I've made a video on this and I'll post that in the top right hand side corner of this video. So now I out 2 is going to be this I ref times W over L, which is the width over the length of the second MOSFET, or M2, over W over L of my MOSFET number 1, or M1, plus I out 3 again is mirrored, so I ref times W over L of 3 over W over L of 1. And again, if you don't understand where this equation is coming from, I would advise you to watch the video prior to this. So then basically now we just go ahead and plug and chug. So then I out is going to be this I ref, which is 4 milliamps, times the width of M2 is going to be 10 nanometers over the length of M2, which is 50 nanometers. Since the nanometers cancel out going forward, I'm not going to write it. So then this goes over the width of M1 is again this 10 nanometers over the length of M1 is going to be this 50 nanometers. So essentially this cancels out with this and we're just left with 4 milliamps. For I out 3, so this is plus 4 milliamps times W of M3 is this 20 nanometers over L3 is 50, all over W of 1 is again 10, and L of 1 is 50. So then my 50s cancel. This becomes 1, this becomes 2. So therefore I out is equated to 4 milliamps plus 4 milliamps times 2, which is equated to 12 milliamps. So this here is your final equation for the first example. If you have any questions, please leave them down in the comment section below and I'll be sure to get back to you. Okay, so let's go ahead now and solve for the second problem. And what I want to note are a couple of things. The first thing is that the current here I'm going to call I2. The current flowing through M4 I'm going to call I4. The current flowing through M5 I'm going to call I5. And the current flowing through M3 I'm going to call I3. Based on our previous knowledge about diode connected devices, we can say or write a solution for I2 and say that it is going to be I ref W over L of 2 over W over L of 1. Again, Iref is this 5 milliamps times 16 over 2. So it's going to be 40 milliamps. And again, the 16 is coming from here, and the 2 is coming from here, and the 5 is coming from right here. Next, I'm going to say again that I3 is equated to this Iref times W over L of 3 over W over L of 1. So Iref again is 5 milliamps. W over L of 3 is 8, and W over L of 1 is 2. So then we're left with 20 milliamps. So now, since this M4 is also a diode-connected device, we can say then that I4 is equated to I2. So essentially the current just flows through it here to ground. So then I4 is equated to 40 milliamps as well. And then my I5 is a mirrored current of my I4. So I5 is basically I4 times W over L of M5 over W over L of M4. So then this is 40 milliamps times W over L of 5 is 10, and W over L of 4 is 16. 40 times 10 is 400 divided by 16. You get 25 milliamps. So now we pretty much know everything to solve the problem, but just to be clear, this current here, I5, splits into two currents, specifically I6 and I3. So then we can use KCL, and we could say then that I5 is equated to I6 plus I3, or that I6 is equated to I5 minus I3, or I5 is 25 milliamps minus I3, which is 20 milliamps. So then this is equated to 5 milliamps. So then V out, which is equated to I6 times my 3K ohm resistor according to Ohm's law, is going to be equated to 5 milliamps times 3K ohms, which is equated to 15 volts. So this here is the final answer. I hope that makes sense. If you have any questions or concerns, please leave them down in the comment section below, and I'll be sure to get back to you. If you liked the video, please give it a thumbs up, and please share the video to your colleagues and friends. And lastly, if you like what the YouTube channel is providing, please consider subscribing. It really helps the algorithm. Thank you.